Well, good afternoon, everyone. This is Rick Nelson. I'm the coordinator for the Plains and Prairie Potholes LCC. I'm in Bismarck. Welcome to our November edition of our monthly science webinar. A couple of housekeeping things. First of all, we're scheduled for an hour. There should be plenty of time for questions. Ask that you hold your questions till the end of the presentation. And at the end of the presentation, you can either ask them via phone or you can write them into the chat box, and we'll get to those then. We are recording this webinar, and we will post the webinar on our website in a day or two, and it should be there. Please take a look at that and share it with anybody you know who may not have been able to make this live broadcast. Finally, please mute your phone so that we minimize background noise, and we'll begin here shortly. So today we are pleased to welcome Chuck Fritz and Mark Deutschman to our webinar. These two gentlemen will be the presenters. I've known both Chuck and Mark for a long, long time. Chuck and I worked on the Red River of the North with the International Red River Board for years, and Mark and I also worked on a big EIS in a previous life that I had, and Mark and I also terrorized the NDSU Zoology Department together for a number of years as grad students. So it's my pleasure to welcome both of them today. Chuck Fritz is the Executive Director of the International Water Institute. He's based in Fargo, North Dakota. In his role as the Director, Chuck works with lots of local resource managers and practitioners to develop and implement applied watershed research and education initiatives in the Red River of the North Basin. Co-presenter today is Mark Deutschman. Mark is a principal with Houston Engineering Incorporated in their Maple Grove, Minnesota office. Mark does a lot of work on large-scale watershed projects, including ecological restoration and water quality modeling. He's recently been involved in developing decision support systems for water and natural resource management decisions, including work on water rights and drought planning. So they join us today to do a presentation on the Prioritize, Target, and Measure application, PTMApp, a very interesting tool that is available to a wide range of decision makers and one that can help in watershed planning, implementation, and monitoring. So with that, I will turn it over to Chuck and Mark. Gentlemen, take it away.
All right. Thank you, Rick. I'm going to start. This is Chuck. So I'm going to go through this. We have a number of slides. We will get through this in time. I'll kind of go through my stuff fairly quickly, and then I'll turn it over to Mark to talk more about the application of these data. Rick mentioned the Prioritize, Target, and Measure application, or PTMApp, and yeah, this presentation will, that's kind of what the core of the presentation is, but I more want to have a discussion about how we're attempting to kind of change the way we do conservation, at least in the areas that we've been working in, and mostly I want to try to maybe talk about how we can use geospatial data to change or to be more successful in the implementation of conservation and best management practices. So with that, I'm going to get started and go into this. Again, I'm going to try to tell you a story here. Basically, the bottom line when we talk about conservation is producers. And again, we want to talk about removing barriers and really using technology and data and information, PTMApp, to create positive dialogue between the practitioners and the landowners out there so we can get implementation on the ground. These are kind of the chapters I'm going to go through. I'm going to take you through the first three. I think that's what we agreed, Mark, and then I'll turn it over to Mark, and then maybe we'll tag team the stewardship discussion. But I'm going to step through all these things at one point during this story. My organization, the International Water Institute, was formed actually in 1997 after the 1997 flood. There was an effort in the Red River Basin called the International Flood Mitigation Initiative, which met for a period of 2 years, came up with 14 recommendations to reduce damages from future floods. 2 of those had to do with forming an organization that would do watershed research and watershed education. That's what my organization does. I work in the Red River of the North Basin, which is the kind of on the border between North Dakota and Minnesota up into Canada, Manitoba, Canada. I have an international board that I work for. I am a nonprofit. Staff right now is actually quite a bit because I have a number of interns, but I have 8 full-time staff, and we anticipate up to 15 interns over the course of the next few months. So that's what my organization is, and you can learn more about it just by Google searching International Water Institute. You're going to see PTMApp. I'm not going to spell it out, but PTMApp stands for Prioritize, Target, and Measure Application. It originally was funded through Minnesota Clean Water Fund, through the Minnesota Board of Water and Soil Resources. The local funding partner is the Minnesota Red River Watershed Management Board, which is the joint powers board of all the watershed districts in the Red River Basin in Minnesota. The project team, the people who developed this, the International Water Institute was lead. But folks at Houston Engineering in Maple Grove, actually, we worked with to develop the tool, and I'm going to give kudos right now to one of Mark's staffers. Drew Kessler is really kind of the programming and the brains behind a lot of this stuff, and he deserves credit. So I'm going to step through this. The idea for PTMApp, or what we call at the beginning, it was these advanced water quality decision support systems, started a long time ago, actually in 2005. The International Water Institute was, I was the lead in developing something we called the Red River Basin Mapping Initiative. At the time, it was one of the largest contiguous LIDAR collection efforts, I think, in the world. We collected about 52,000 square miles of LIDAR data. And really, since 2005, we've been working with that LIDAR data in a number of different capacities, but basically applying LIDAR data to help people make better, more informed decisions. And at the time, back in 2005, when we started working on this, I didn't even know what it was called, but we were doing something called terrain analysis, which is really kind of the basis or the premise for PTMApp. But as we started to develop it, we started to develop these watershed planning tools. We started to develop these what we called advanced water quality decision support systems, and eventually all of these efforts kind of culminated in this thing that we're calling PTMApp. The goals of PTMApp are relatively straightforward and simple, and we actually developed these goals after talking with practitioners in Minnesota, the folks at the Soil and Water Conservation District, but it's basically we want to change how decisions are made with the implementation of conservation practices and how those decisions are made. I wanted to develop something that was one-stop. I didn't want to have something where folks had to go everywhere and different places to find information to pull it together. I wanted something that was a one-stop shop for implementing and prioritizing practices. I wanted something that would target specific lakes and rivers, and we wanted to be able to estimate the effectiveness of one or more practices, either in series or parallel at multiple spatial scales. Those are the goals of PTMApp, and we did accomplish that. Just real quick to give you an idea where PTMApp is being developed or underdeveloped, the area that's here on the map, the entire state of Minnesota will have PTMApp at some point in the future. I'm currently working on the North Dakota portion of the Red River Basin. That's kind of one of the biggest projects that we're working on right now, and then of course you can see some work down in Iowa. But PTMApp is becoming an accepted application to develop these advanced or these geospatial products for looking at BMPs. What is PTMApp? Quite simply, there's the URL. If you want to learn more, you can go through this, but I'm going to step through very quickly kind of what the nuts and bolts or some of the theory is behind the PTMApp, and you can learn a lot more at that URL that's at the top of the screen right now. But we use a grid-based approach. It is entirely an ArcGIS or a geospatial analysis type thing. Basically, we break the interest into cells, and we are using 5-meter cell for the most part, but we give each cell a value. You know, the values for what we give them they're many and varied. We actually route our loads to a specific area of interest that I'll talk about in a minute when we do that using a first-order decay function. The sediment values that we look at, and one thing I will say is we do not speciate. We don't, for nitrogen and phosphorus, it's total phosphorus, total nitrogen, total sediment, but we use the Russell to get our sediment values, and we use values from literature to get our nitrogen and phosphorus values. Again, if you want to learn more about the methods, there's webinars that we've recorded, and there's a ton of literature that you can obtain at that URL on the top. There are two components to PTMApp. The first is actually the toolbar, or what we call the PTMApp desktop. It is available, and you can download it at the PTMApp website. It's an ArcGIS toolbar. You basically put it into your toolbox, and it is a ArcGIS. It's part of a tool. And then there's something, the PTMApp web. One of the things that as we were developing this, I knew that I didn't want to have people, I didn't want to restrict the access to PTMApp to people who only knew GIS. And so we developed something called the PTMApp web, which takes the products from the desktop and puts them into the web format so that people can access, view, and use the data from the PTMApp desktop. One thing I will say real quick right here, the PTMApp desktop, you should have some fairly advanced GIS skills to do it right because of the development of the inputs and other things. But again, there's much more information on the documentation that you can learn about. What I'm going to step through very quickly here is some kind of broad overview. I'm going to give you some examples of PTMApp data, and then I'll turn it over to Mark, and he's going to kind of bore in or peel the onion back to get down to the finer scale stuff that you can do with PTMApp. But I mentioned earlier that PTMApp was a one-stop shop. This pinwheel that we developed really is a watershed planning steps, right? It basically, we try to describe all of the steps in a complete or a comprehensive watershed planning effort. PTMApp allows you, the toolbar itself and the PTMApp products, you can do all of these things, okay? And so I'm going to step through real quick and show you some, some products from the PTMApp desktop output. When we talk about describing your watershed, we break the watershed into catchments. Those catchments range from 20 to 140 acres. And you can see the pink outlines there are actually the catchment boundaries generated by a conditioned digital elevation model. And then what this is depicted is also flow paths, and the flow paths are color-coded based on the number of acres that they drain. So that's your describe your watershed. We do watershed or water travel time. We basically look at the grids and look at the time water takes to move from a cell to some point downstream, and we do that in hours. When we do the event base that we look at in this tool are 2- and 10-year events, and Mark, you'll probably talk about that in a minute when you go through some of the benefit cost stuff. I spoke about priority resource points earlier. Again, in PTMApp, we are able to route loads, nitrogen, phosphorus, and sediment loads to anywhere the user chooses. The red dots that you see on this map are actual priority resource points chose for Mille Lacs Lakes in Minnesota. But those priority resource points are areas that we basically generate loads to in PTMApp, and they can be as many and as varied as you want. These happen to be outlets of lakes, inlets to the big lake, but you could have a reach that you have a concern about, whether you want to improve it or protect it. But you basically, in PTMApp, you identify what your priority resource is, and you establish those points in PTMApp, and as the toolbar runs, it delivers loads to each of those points. This is just an example of sediment delivered to lake by catchment. Let me get my notes here quick. And this is in tons per acre per year, and again, we do that for a 2-year and a 10-year event. This happens to be runoff volume, again, 2- and 10-year event. This happens to show the 2-year, 24-hour runoff per catchment to the lake. PTMApp does something called BMP suitability. This is actually evaluates the practice feasibility. This happens that we put the practices into different categories. We have source reduction, storage, protection, filtration, biofiltration, and we have a user-defined category also. But we actually look into each catchment and we identify those parts of that catchment that are feasible to do each one of these different practices. And so that gives you an idea of where you can give a specific practice, and you can see the colors there, and you can see the kind of detail that we're looking at. This depicts the effectiveness of filtration. We also have an economic component to this. This depicts the filtration practice and its effectiveness. So this basically looks at the cost of the reduction in mass total phosphorus in pounds per year in that Mille Lacs Lake watershed. This is filtration effectiveness. And so this is the preferred target location. This is just the mass reduction in a total phosphorus from each of the catchments going into the lake, and we just put them into 3 different categories. And again, Mark's going to go into a little more detail here about how to take these data and put them into a watershed plan. This is just basically a recommended practice location looking at storage, filtration, and protection. But what we can do here once we have the PTMApp data is we can look at the best locations for practices. We can determine the best location based on whatever you want, the lake or a stream reach. We can assess the combined benefits of those practices at many locations. We can estimate the life cycle of the costs because we have economics in here, and we can develop benefit cost curves that Mark is going to show you in a minute. But the bottom line here is this information, we want to use this information to increase our chances for success, and chances for success are twofold. A, having a landowner implement a conservation practice, but to do that in a way that you can show is attaining some goal that you've established earlier. So I'm going to turn it over to Mark now, and Mark, you can just have me step through the slides as you go through this, and I'll go ahead and do that, okay?
Sounds good. Thanks, Chuck. Can everyone hear me okay?
Yes.
All right. Next slide, please, Chuck. So Chuck showed you some of the products that are available for the purposes of watershed planning, generally at a larger scale, looking at where to target practices within a watershed, where they're most cost effective, their benefits. Because the data that we're generating is being generated at that fine scale that Chuck mentioned, the digital elevation model scale, the 3x3 meter raster or 5x feet raster, whatever the user chooses, we're also able to create implementation products. And these products are primarily geared at discussions with landowners and engaging landowners in discussions about conservation. So what I'm showing you here on the screen are some of the product categories that we try to brand using PTMApp. Those green boxes are products that help you prioritize something specific to the field. The brown colored boxes to actually target where the practices go, and then the blue ones to estimate the benefits of the practices. Next slide. So Chuck showed you a travel time map for the Mille Lacs Lake watershed that shows how long it takes water to move. He also showed you a catchment map. So what we're doing here is we're literally just zooming in on a particular field, the idea being that this would be a product that you could use to engage a landowner about water movement across their particular field or their farm. The red area here shows you the parcel boundary or the field boundary. The blue lines are the flow paths across that field, and then the black lines are the actual catchment boundaries. The other thing that you'll see on this graphic are some yellow-colored areas that shade off to kind of a brown color. That information is some of the base information that's generated. It's called a stream power index. Loosely, the way to think of it, it's areas of high flow and then also high sediment yield. And so those would be areas that when you're engaging a landowner in a discussion about where gully formation might occur or where there might be high sediment loss, those might be areas that you want to focus on. Next slide. The calculations within the prioritized target measure application are being done again at a fairly fine scale. We're actually applying the revised universal soil loss equation at the raster scale. Again, the raster scale is defined by the user. As the areas get larger, you probably want to go to a little larger raster, maybe a 10 meter by 10 meter grid. Typically, we've been running this at a 5 meter by 5 meter grid. So what I'm showing you here is the sediment tons essentially delivered to a waterway. Those areas that are darker in nature or darker in color, those are the areas with the highest tons per year of sediment that actually make it into a waterway and actually then get transported downstream. So this would be a product Again, where you might want to engage a landowner in where are some of the critical areas within their field that have the highest erosion potential or potentially losing the largest amount of sediment. And those would be areas that you might want to target, say for cover crops or perhaps some other conservation practice. Next slide. So Chuck also showed you the prioritized target measure application results for the Mille Lacs watershed, showing where there might be opportunities for practices like biofiltration or filtration or storage or reducing movement of sediment from the field because of cover crops. I'm showing you basically the same product here, now superimposed over essentially the field boundary. Again, because these data are generated at a very fine scale, it allows you to identify opportunities for conservation. Now, these are technically feasible locations. We all know that there's other factors that come into the decision-making process as to how any given landowner or why any given landowner might implement conservation on their property. This is just the technical feasibility piece. What we're actually doing here is applying various criteria, many of them from the field office technical guide the NRCS has, to determine where these locations are. One of the neat things we think about the data and the information that's generated is for areas, say, that might be storage potential, some of those blue areas. We actually have characteristics associated with those storage areas, what their drainage area is, how much sediment and phosphorus and nitrogen they receive, their effectiveness in removing that material as it moves downstream. And so we're able to use that information in cost-effective analysis to try to rank some of these practices in terms of their best to worst, so to speak, or most effective to least effective. And because the prioritized target measure application data that we get contains information not only about the reduction at the practice, but also at all of those red dots that Chuck showed you in the earlier slide for Mille Lacs, we're able to evaluate practice effectiveness at multiple spatial scales at many different lakes and reservoirs or river stream reaches that might be located across a watershed or within a watershed. Next slide. One of the things that you want to do is to try to target where to put those practices. So I showed you in the last slide technically feasible locations. This is basically the source of the sediment. Where are the sediment sources the highest? Again, we're actually developing this information at a raster scale. Here we're summarizing it at that catchment scale boundary. So those dark green areas are areas with the highest sediment that's actually leaving the landscape. So those might be areas where you want to intersect practice feasibility with the amount of material, the amount of sediment or phosphorus or nitrogen that's moving off of the landscape. Next slide. And not only in addition, you may decide to cite practices based not only on where the largest mass comes from, but also cost effectiveness to reduce that. And that's what I'm showing you here. Again, same slide as Chuck showed you at the planning level scale for Mille Lacs Lake, but this happens to be at the field scale. Because we have estimates of the practice costs, we're able to rank them in terms of their effectiveness. The idea being that, again, you would be able to identify those practices that remove the most material for the least amount of cost. And again, not only at the field scale, but also at other locations downstream. Next slide. And so what that allows you to do then is to combine the information sources and do something like this. This is a slide from one of my colleagues, Dr. Drew Kessler, that I borrowed. Basically what I'm showing you here is at the field scale, a plan that might be focused on how to best place conservation, again, purely based on technical criteria, no trafficability consideration from the landowner or profitability consideration from the landowner, but a plan that is aimed at reducing sediment loads or phosphorus or nitrogen loads downstream to the various waterways. On this particular graphic that I'm showing you I'm showing you where buffer areas might be feasible based on the red line. I'm showing you an area where filtration practices might be possible, essentially grass swales and grass waterways indicated by the brown area. You're seeing some areas in yellow that require protection because of concentrated flow and high quantities of sediment. So the point is that you can actually use this information again to engage a landowner about what opportunities there might be for conservation, but more critically to try to fit some of that information into the landowner's decision making as well, specifically explaining what some of the benefits might be locally and some of the benefits regionally as well in terms of water quality improvement. Next slide. So at the end of the day, what it allows us to do is provide some estimate of the benefits of these practices in combination. That's what I'm showing you basically here, is that given the various practice types, what would be the estimated reductions in tons per year of sediment, for example. And that's important because typically landowners want to know or have some information if they're going to do something, what are the benefits expected to be. Next slide. So I'm going to talk a little bit now about how the planning level data that Chuck showed you could be used or can be used to develop a plan for addressing water quality issues for a particular watershed. Next slide, Chuck. And so the one thing that I want to reinforce again is that the information that we're able to get from the prioritized target and measure application is available for many different spatial scales because we're actually doing the calculations at a very fine scale, at a subfield scale, so to speak. We can accumulate those into larger spatial scales and use that information to plan at many different levels. And so what I'm showing you here in the upper left-hand side is we can use the data at a field scale, but then we can use that at increasingly larger scales. We might have a particular lake that we're interested in trying to manage. We can use those data to develop a lake-specific management plan, or maybe we're trying to do planning at a 12-digit or a 10-digit or maybe even 8-digit HUC scale. And so we can use those same data to address, say, regional sediment reduction goals or maybe nutrient reduction goals that might be in a nutrient reduction strategy developed by a state agency, say. Next slide. So one of the things that we can do in assembling the watershed plan is that we can basically rank practices from best to less best, if that's such a word. And best can be defined in a couple ways. It could be defined purely on the magnitude of the sediment, phosphorus, or nitrogen reduction that reaches a specific lake or maybe reaches the edge of field. But we could also do it based on cost effectiveness, which is generally what we like to do. So because we have an estimate of the practice cost and we have an estimate of their various load reductions, we can convert that into an estimate of essentially the cost to reduce some unit of nutrient or some unit of sediment. And that's what I'm showing you here in this particular table, the ability to basically rank the best practices, again, purely based on technical feasibility, and use that either in a grant application or use that to engage landowners in a discussion about where practices are best within a watershed. Next slide. The other information that we believe is very useful is to take the data from the prioritized target measure application and do some sort of a benefit cost analysis. This curve is called an efficiency frontier. Because we've ranked those practices from best to those that are less effective, and because we have an estimate of their benefits in terms of the load reduction, and because we have an estimate of their cost, in this case we're using 2015 equip cost numbers, we can generate a curve that looks like the blue line. And so on the x-axis, I have the cumulative equip cost essentially of those practices moving to the right, and on the y-axis is the, in this case, it's actually the total phosphorus reduction, cumulative total phosphorus reduction. The blue line then represents the idealized condition or the optimum condition that we could expect from implementing the practices from most cost-effective to those that are less cost-effective. And in this case, this is actually total phosphorus reaching Mille Lacs Lake. This work was done to develop a protection strategy for Mille Lacs Lake, the idea being to reduce existing loads by a certain amount. In this case, the protection strategy consisted reducing the load by roughly 1,100 pounds annually. That's the red line. That line represents the load that comes from surface runoff, the load that you would measure in a stream, say if you had stream flow instrumentation out there and were taking samples. The good news here is that under ideal conditions, the blue line actually intersects the red line. And the implication at that intersection point is, number one, the goal is technically feasible. If the red line didn't intersect the blue line, it would suggest that achieving that load reduction through surf practices on the ground that manage surface runoff only aren't going to be able to get you to that goal. And the other advantage of plotting this is that you can see the intersection of the red and blue line, and so if you pluck the number off the x-axis, that's the estimated equip cost to achieve that goal. Obviously, when these practices are implemented, they're not going to follow the blue line. They're not going to be perfectly effective. So the reality is you're going to have to implement more practices to achieve that load reduction than is suggested by the efficiency frontier. The other thing that I'll point out here, this is one of the next lakes, the downstream lake called Ogeechee Lake. A couple things that I want to mention here. You'll notice that the red line does not intersect the efficiency frontier, does not intersect the blue line. That suggests that achieving the goal purely based on managing surface runoff isn't likely. That makes sense for this lake. This is a very shallow lake where there's likely all kinds of other sources of load, probably predominantly driven by nutrient recycling from the sediments. But the thing that you can do with this graph is if you make assumptions, often we don't have or we don't know the actual amount of load that comes from surface runoff. The different colored dashed lines represent an assumption of what that might be. So if you assume, for example, that 25% of the load comes from the fields, that would be kind of that lighter lower line that's dashed, and that does intersect the efficiency frontier. So one of I think the real powerful things here is you're actually, now being able to look at the investment that you make relative to the load reduction and the goal, and get some sense of whether the goal is feasible. And typically those goals come from load allocations or from some other information, and then also the cost of achieving that reduction. Next slide. And so very briefly, what we've been doing is for a lake like Mille Lacs, developing what we call an implementation profile. It's intended to be like a 2-page document that you can give to a county commissioner or the policy decision makers that describes what the goal is, what you have to achieve, shows the efficiency frontier, and shows those best practices. So this really becomes our communication piece. Next slide, Chuck.
So maybe I'll start this off, Mark, just real quick. When I have discussions or I make presentations about PTMApp or geospatial data or changing the dialogue, this concept of rural stewardship is something that I've heard a lot about in the last 20 plus years of working, and you hear these blanket statements about stewardship, who's a good steward, who's not a good steward, who should be the good steward, and really I've been asking questions about this for almost pushing 30 years now, and that is, well, what is good stewardship? What do you mean? And really to be able to put some threshold or at least to start the discussion with landowners about what stewardship is and is not, is an incredibly important discussion. I think that helps us to change the dialogue about what it is we're trying to do and how what we're trying to do is lockstep really with what every landowner should try to do. And this is kind of the exciting part about these data PTMApp, a lot of the technical data that are out there now, precision, conservation, all these things. But, you know, there are benefits to stewardship as long as you can properly define it and put thresholds on it, right? I mean, we all, you know, we have a goal, those of us maybe on this call have a goal of improving water quality. And that may not be what a landowner wants, but certainly the landowner wants to increase his yield and thereby increase his profit. And I would argue that increasing the yield isn't quite as important as increasing his profit margin on each individual field. And one of the things that we have to get to in order to properly and successfully engage landowners is to start to have this discussion about what it is that conservation properly done and in the right way can do for us, but also what it can do for the landowner. And this is the part. This is the stuff that I get. This is what kind of you know, sticks me in the back a little bit to get moving. I get excited about this stuff because when I have this discussion with landowners, and I have a lot of discussion with landowners in the Red River Basin, you know, I can see them. You can just see them kind of peek up and listen, right? Because they get this stuff. Mark, do you got anything to add? And then I'll just turn it back over to you to do the rest of the slides here.
No, I could keep going.
Yeah, okay.
So one of the things that we've been trying to do with the data, and again, because they're generated at a very fine scale, is to identify and characterize the environmental outcome benefits of stewardship. And so we define stewardship using these 6 metrics that I'm showing you on the screen. Essentially what we're trying to do is identify areas and identify fields in particular that have high amounts of sediment or high amounts of phosphorus or high amount of nitrogen, that have structural practices that might reduce those high loads reaching the field edge, to identify those same fields in terms of what management practices are potentially being applied on them, fertilizer management practices, for example, and then to set a soil health goal for the watershed that's connected to stewardship. And so based on those first 5 metrics in particular, we place rural stewardship in one of the 3 buckets that I'm showing you on the bottom of the screen. So for example, if the sediment loss is high, the likelihood that it needs stewardship, the stewardship metrics is low, and it goes into the probability low bucket. Because often we don't know where the structural practices or the management practices are, nor do we know their effectiveness, we kind of give things the benefit of the doubt. They might have high sediment loss and high phosphorus loss, but if they have a practice, it could reduce that loss to the edge of field. And because we don't necessarily know the effectiveness of that, we put them in the probability depends bucket, that middle bucket. Okay, so those are the metrics we're using to define stewardship, ultimately setting a goal for soil health for the watershed. Next slide. So what I'm showing you here is the very first metric for the sediment vulnerability threshold. We actually define this statistically. We don't define it from an agronomic perspective. If it exceeds, the threshold itself is based on the upper quartile of sediment delivered to the field edge. What I'm showing you here is those areas that are finally hatched black are areas that end up in the above threshold bucket, essentially, or they're above the threshold. So this would be a tool that you could use to engage a farmer with or some other landowner. The areas that are shown in dark red, those are areas of the highest sediment loss, so essentially those are critical areas. What this shows sometimes is that the even though at a field scale that sediment loss might be high, it can come from a relatively small amount of the field. And again, this is based on the revised universal soil loss equation that's being applied within the prioritized target measure application. Next slide. And so same concept. This just happens to be the total P vulnerability threshold, where those areas in red are high total P losses. And then again, the dark, the boxes with the, or the polygons that have black outlines, those are fields with high total P loss. Again, so they, essentially, those are the ones that are not, that are failing essentially that total P vulnerability threshold. and because of that, they go into the probability low stewardship box. Next slide. And so within the one area where we've applied this, it's in the North Fork Coral Watershed. This shows the watershed, and in inset you can see where that's located in Minnesota. The black areas are the planning regions. Those are essentially the areas that we have reduction goals for sediment and nutrients. Next slide. We've actually then tried to estimate the total acres within each of those planning regions and within the watershed in each of those stewardship buckets. And that's what I'm showing you here. Roughly 49% of the watershed in total falls in the probability low bucket, meaning that they don't meet those metrics. 15% falls in the middle, and then 36% in the probability likely meets the stewardship classification or designation. My sense is that the reason this is fairly low is that we don't have a lot of data on where practices are actually located, and that if we had better data, the numbers might look a little different. Next slide. And then what we're trying to do is use those stewardship acres combined with information about soil organic matter as a surrogate for soil health to set a watershed-wide goal. The idea is that we want to increase some proportion of the water soil health on some proportion of those low stewardship acres within the watershed. The way we would likely do that is through use of something like cover crop adoption or various fertilizer management practices or conservation tillage to increase residue, those things that increase organic matter. Next slide. And so if you superimpose the soil organic matter content information, again, as a surrogate for soil health, and you focus on those acres that have more than 1% soil organic matter and less than 4% in the probability low bucket, if you look at that first row, about 31% of the total acres in this particular watershed would be targeted to increase organic matter. If you include the second category of stewardship, it'd be roughly 40% of the total cropland acres. Next slide. And if you assess and try to estimate the environmental benefits or outcomes of stewardship, specifically related to runoff volume reduction, which typically shows up as a concern for eroding stream banks and for stability, geomorphic stability, and sediment transport in general. In this particular watershed, we had a goal of about 96,000 acre-feet of volume reduction on an annual average basis. If you assume that by increasing that organic matter, improving soil health on those 40% of acres, you can essentially accomplish 7,000 to roughly 14,000 acre-feet of volume reduction in this watershed by improving soil health through the increasing of organic matter on those acres. Next slide. Within this particular watershed, the sediment goal at those pour points at the 10-digit HUC scale typically is for a 20% reduction on an annual average basis. So what I'm showing you here is our estimate of the environmental benefits of stewardship at the 10-digit HUC scale. The numbers in the table are the the estimated percent reduction in annual sediment load. So essentially this suggests that if you apply cover crops, conservation tillage, other practices to improve soil health by increasing organic matter content, you could achieve the sediment reduction goal in this particular watershed for those 10-digit HUC planning regions. Next slide. And we also estimated the environmental benefits or outcomes of total phosphorus relative to total phosphorus. Typically the goal here is 40% reduction, not unlike what it is in Iowa for their nutrient reduction strategy. Minnesota's actually is based on a change from 2000 condition or something like that. I probably have that wrong. But 40% estimated load reduction goal. Essentially, we get about a third of the way there by, again, trying to improve soil health by increasing organic matter content. on those roughly 40% of the acres within the watershed. The table shows you the estimated reductions for each one of the planting regions. The assumptions that I made here are fairly conservative. So, for example, I assume that cover crops would reduce the total P loss on any given field that they were applied by 20%. It's likely higher than that, but I was trying to be cautious, if you wish, on claiming the benefits of improving soil health. Next slide. And so one of the things we like to think about here is that some of you may be familiar with field to market. What I'm showing you here is a graphic of the sustainability metrics that field to market uses. Two of those metrics, one is water quality and one is soil conservation. Soil conservation is basically soil loss. You'll notice that the water quality happy face is upside down, and that's on purpose because they're still kind of working on that. And really, I guess this is more of a thought question, but maybe the metrics that we use for stewardship would have some utility in terms of the metric for water quality for field to market. The idea being is maybe if that could be used to demonstrate progress toward that metric, there might be an opportunity for private investment in some of those conservation measures. Next slide. So, you know, in theory, we haven't proven this yet, but what we're trying to do is connect rural stewardship to the various environmental outcomes from the scale, and then try to achieve or try to stimulate private investment in conservation. Next slide. Someone needs to mute.
6.8 hours.
And then the other thought that I'll leave you with is that, you know, what is the value proposition of the landowner here? And, you know,
hey, Mark, let me break in for a second. Somebody's got their phone not on mute. Could you please mute your phone, please?
I was doing my best to ignore.
That's good.
And so, you know, if we think of the old land ethic, you know, most landowners, I guess, we feel like they want to protect the legacy. One of the ways that they can protect their future legacy and farming into the future is to try to minimize that soil loss from the fields to maybe what the rebuild rate is. But we think that this whole stewardship notion connects with the value proposition of the landowner, which is a legacy for farming into the future. Next slide.
So you want?
And so we think that this, you know, the information that you're seeing really kind of changes the dialogue and helps us communicate a more believable story depending on who the audience is. But we're really just trying to connect the value proposition of the landowner to the value proposition of others in the public community that are interested in water quality and improving the environment. And I'm not in any way suggesting that the landowners aren't interested in that at all. It's just that the landowners have an additional value proposition that they're trying to make money on their farms and they're trying to run a business. Next slide. And so just some closing thoughts for you on stewardship is that, again, we're using soil organic matter as a surrogate for improving soil health. Some of these concepts, you know, I think are still open to discussion. Does, you know, increasing soil organic matter increase yield and profits? We believe it does, but there's still some research looking at that. Improving soil health should improve the long-term sustainability, the idea being that yields would increase and that we can make a certain amount of progress towards some of these environmental outcome goals by stewardship, and then we have to tack on top of it some of those the investment that's required for those structural practices. Next slide. You want me to do this one, Chuck, or?
No. This is fine. You can kind of read the bullets, but the bottom line is like I said, it's about using information to create a better dialogue, and the goal here is implementation that kind of meets the goals of both a watershed manager, local government, whatever, and the landowner. I mean, that's the bottom line. So that's all I had. And Mar, I want to thank Mark up front here for helping me with this. Mark and his firm do much of the actual application of these data. My role is more generating them and kind of working on the inputs. So if there's any questions, I guess now would be the time to ask them.
Yeah, go ahead, folks. Anybody have a question for Chuck or Mark? The line is open, or you can write it into the chat box. Any questions from anybody? Well, I'll ask one, Chuck, and Mark, you can chime in here too. So in the context of stewardship, in where you've started to apply this, have you seen a change? I'll call it attitude. Maybe that's not the right question. But has there been a little bit more open dialogue taking place when you've talked to landowners about these things? And, you know, it seems like in the past it's been quite adversarial in many places. Are you seeing kind of a shift? Is this working in the context of really hitting on what's important to the landowner versus folks coming out saying, boy, you got a bunch of great programs. If you'll just put them on the ground, we can really fix the problem we have at Lake X.
Yeah, no, I'll start and then I'll let Mark add. I mean, here in the Red River Basin, I mean, it's most of the soil and water conservation districts in Minnesota that are using these data, and it's not, you know, they're not available everywhere right now in Minnesota. They will be. But one of the, probably the most, the most apt example would be what's been done in Becker County. There's a young man that runs that by the name of Peter Mead, who is a GIS. He's very skilled in GIS, and he's really taken these data sets and adopted them. And, you know, there are two things that are happening. A, his soil and water conservation district is out competing others for money from grants from the state for implementation of projects. And B, he's able to implement them because he's engaging landowners using these data, and the response that he's been getting is quite remarkable given the fact that he's working right in the heart of the Red River Valley. So, you know, I've seen it on a number of occasions, but that's probably the most striking.
What I would add, Rick, is that, you know, these concepts we're showing you are literally hot off the press. We're just getting to them. I think the answer is any time that you can connect to the value proposition of a user group, you're going to make better progress. What I didn't show you is that the best way to start that dialogue, in our opinion, is to start intersecting some of the information we're showing with the precision ag data. And some of you have maybe seen or know that now many of the producers can complete profitability mapping. And so when you start to intersect that kind of information on discussion around where conservation practices are possible, it does change the dialogue, and I think you do get further because you're recognizing that someone's still trying to make a living on the landscape.
Thanks, you guys. I appreciate that. That's important. Anybody else have a question? I'll just add a commentary. I've been kind of working on this stuff for a long time too, and that value proposition thing I think is a real key concept here that I really appreciate you guys spending a lot of time talking about that. Other questions for Chuck or Mark or both?
Hey, Rick, I did pull up, and you should be able to have seen it. I mean, this is the documentation for a lot of the theory, how we created, what's behind the scenes going on with the calculations and stuff. You know, there's a ton of information here, including a series of webinars that we kind of went through all these things with. But you can get it here at this site. You can also access the PTMApp web to be able to get on and look at watersheds. But the big thing is, if you want to learn more about the PTMApp and what's going on behind the scenes, this is where you go.
Thanks, Chuck. One more time, anybody else have a question they'd like to ask? Got a couple of minutes yet.
We must have done a hell of a job explaining stuff, Rick.
You did. You did an excellent job. Thank you. Well, So this is the second time I've seen your presentation, Chuck, and I got a lot of it the first time, and I got even more out of it this time. So, well, it is about 5 minutes to 3, folks, so unless there's any other questions, and having heard none, I would like to again thank both Chuck and Mark for an outstanding presentation, and thanks to all of you for joining. Our next webinar will be December 6th, and we'll be sending out an announcement about that via our website and via email. Once again, we did record this webinar. We will be posting it on our website in a couple of days. And for more information or to ask questions you didn't feel comfortable asking on now, you can get a hold of Chuck and Mark, and we'll post their contact information as well. So again, Chuck and Mark, thank you very much. Appreciate your time. And with that, everybody have a great afternoon.